All right, so we are going to talk about point 4a or day 1, same deal here. And we are analyzing graphs of polynomial functions. The main topic of today are these vocab points that we're talking about here first, okay? So relative maximum would be the highest point in a neighborhood. Okay, what I mean by that is if I could break this up and have a maximum, that would be then a relative maximum. So somewhere right about here would be a maximum point, like a peak that you see here. So obviously relative minimum would be something very similar. It would be the lowest point in a neighborhood. So we have something like this, where that would be our relative minimum. Because if we cut the graph into something like this, we have a parabola where it is our actual minimum. So it's a relative minimum for this. Maximum number of turning points. This one's big. The maximum amount that you can have is the degree minus 1. Could you have less than that? Absolutely. But you can have at most the degree minus 1. So if we have 3, 4, you can have at most the turning points 3. Okay, it could have 2 or 1 or 0, but it needs to have at least, or it could have at most 3. Okay, and the other big one is talking about your maximum number of zeros. That is always going to be 3. And again, if you think about it, our x squared, 2, 1, or 2 imaginary, which is 0, right? But at most we could have 2. Talk about points again. Increasing to decreasing. So these are your relative maximums or relative minimums. So you focus on how many of those you have, and that would be the number of turning points you have as well. All right, so we are going to state the degree, the maximum number of turning points, and the maximum number of zeros it could have, and then we're going to describe the end behavior. So on this one, it is in standard form, so our degree is 4, which means our maximum number of zeros is 4. Could have less, but our max is 4. Maximum number of turning points is at 4 minus 1, which gives me 3. Now, since this is an even function and it's positive, it would look something like this, where it would both be going towards positive infinity. So we will both be going towards positive infinity here. On the next one, this would be degree 3 because it is in standard form. Our maximum number of zeros would also be 3. Maximum number of turning points is that degree minus 1. So it would be 2. And then our end behavior, because this is an odd and negative, this would be decreasing like this, right? Or you can remember that it would be the opposite of what our x values are. So if it goes to the right, it would be decreasing, and as it goes to the left, it would be increasing. All right, so for the next example, we're not going to get an equation. We're just going to find everything based off of the graph. So in describing end behavior, the first one, it says as x is going to the right, f of x is going up, which means it would be going towards positive infinity. I don't know what happened there, sorry. Then as x is going to the left, f of x is going down, which would be towards negative infinity then. Number of turning points. So this one, you can actually see it. So we have 1 max and 1 minimum, which means that we are going to have 2 turning points because it goes increasing to decreasing and then decreasing to increasing. So that would be 2 turning points. The number of zeros we have, or how many times it crosses the x-axis, which would be twice. Now, because of this, our smallest degree would not be 2, it would have to be 3. If you think about it, 2 is always a parabola, and this does not look like a parabola, but it has to at least be 3. And that based off of your turning points too, because remember that's always at most your degree minus 1. So it could be 5, it could be a 7 graph, but it has to be at least 3. Approximate 0, so as we have in green, it is crossing at -1, 0, and it's crossing at 2, 0. Relative minimum first, so the lowest point would be a 2, 0. And the relative maximum would be one of our peaks, which looks like it's basically at 0, 4. Domain, looking at the graph all the way left and all the way right, would be everything. And that actually applies for the range as well. We have an arrow going down and an arrow going up, so that means both of them negative to positive infinity. So now I already have this written in here. These are the exact same things that we've been doing. They want you to find your relative maximum and minimums, and they want you to find your zeros based off of a graph. So the only way for us to know how to do that is by graphing on your graphing calculator, okay? So we're gonna do that in a second. So go ahead and get out your calculator. So once you get your calculator all set up, go into your y equals and type in the equation. Okay, so we have x cubed minus 4x squared minus 2x plus 3. All right, so the first thing it asks us for is the approximate zero. So we are going to graph it. And sometimes it takes a little while to get there. But then we see it's crossing the x-axis at 3 points. So we can use second trace to calculate all of those. You can, if you wanted to, look at the table, and you might be able to find a 0 in there. Now remember, it's 0. So if you arrow up, you might be able to see one, which we do right now. So that first one is at -1. Okay, you don't have to do that for every single one. You don't have to do it at all if you don't want to. But, oops, sorry. The first one that we see is at -1, 0. So it's one less time for me to go through the process. Now this process that we have to do is the same thing that we've done before. Second trace, and then we would go down to our 0. Then we have the left bound and the right bound. So I want to be to the left of this 0, and then to the right of that 0. Hit enter twice, and then it'll give me the 0 of 0.70. Then we would end up doing the exact same thing with the next one. Second trace, go to our 0. Now we need to go to the left of the next one, which again, you can really go wherever you want. I always just go far enough away that I know it's off the x-axis, but not so far that it's including too much. So then they tell us that the next one is 4.30. Okay, so we are going to follow the exact same process for the next one. Okay, so I'm going to graph these first. -1, 0, 0.70, and 4.30. Okay, so now let's find our maximum and minimums. So we'll go to our graph. Same deal, second trace, and now this time we're going to go to maximum first. Okay, so my relative max is obviously somewhere close to where x is 0, but it doesn't look like it's quite there. So again, this tells me left bound and then right bound. We'll keep going. Okay, so I'm somewhere to the left of it, and we go somewhere to the right of it. Hit enter twice, and then it tells you that my maximum is -0.2 and then 3.2. I'm going to graph that point. Right about there. And then we'll do the same thing with our minimum. Second trace, go to minimum. We're going to go over to somewhere to the left of it. Right there, sure. Doesn't matter, remember. We just need to make sure we come to the right of it. Again, doesn't matter really where. So it's going to find the minimum between that, and it's 2.9 and then negative 12.1. 2.9, negative 12.1. Oh, gosh, that's supposed to go here. So we have 2.9, negative 12.1, somewhere like this. Okay. So at this point, we could draw our graph through these. So we can just kind of estimate the rest of it. We know it's going to be something like this. And there's our graph. Okay, so I encourage you to try these out on your own before you watch me do it, and type it into my calculator and whatnot. Okay, so I'm going to type this next one in. So we have y equals, I'm going to clear it completely, x to the fourth, and then it's minus x cubed minus 4x squared and then just plus 1. They're all minus, correct? Yep. Okay, so we hit graph, and it graphs it for us. Again, sometimes this takes the calculator a second. So as we can see, we have two relative minimums because there's two parts where it's like a valley and one maximum. We do have 4 zeros. So again, I'm going to use second table to try and identify a 0 first, which again, remember is where y is 0. And there's nothing really popping up with y being 0. As you see, they get really high really fast. And I don't see anything popping up. Okay, so no zeros that aren't going to be decimals. Okay, so again, we're going to do second. Oh man, I hit it too many times. So we'll pause it for a second. All right, so again, you can hit second trace, and I'm just going to do one of the zeros, and then I'll pop up the answer here in a second. So again, we go to the left of a 0, and again, it doesn't matter where it's at. And you hit enter, and then it says right bound, so you're going to go to the right of it. You don't want to go too far because you don't want to include too much of the graph. So I'll stop there. And then if you hit enter one more time, we would get a 0 of negative 1.40, and then we would have to do the process for the rest. Okay, so go ahead and pause this, do the rest of them, and then I'll show you what you should have done. All right, so hopefully you got answers that were close to this. One thing I do want to point out is that sometimes this, like for your x's, pay attention because it was like 1.1 dot 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 dot, and then it was like e to something. That basically means 0. Okay, that means that it is in scientific notation, and it's saying that it's so stinking close to 0, but it's not quite 0. So always just round it to 0 if that's the case. Okay. So go ahead and do the same thing for number 3, and I'm going to post the answers here, and just go to your OneNote and check those so you can make sure you're doing it right before you get started on your homework. Okay.